This chapter is about ratios and percents, which is pretty reasonable after the chapters on fractions, because any ratio can be written as a fraction. To write a ratio comparing measurements, such as units of length or units of time, if you want the ratio to be unitless, both quantities must have the same unit of measure. Because, well, what is the fraction of 1 minute per 2 minutes? Oh, hey, the minutes cancel out. So this is equal to 1/2. So 1 minute is half as much as 2 minutes. Okay, what about, say, I went 100 kilometers in 2 hours? Oh dear, okay, the units do not cancel out. So this is 50 kilometers per hour. That's still a ratio, but it's a ratio between different units, so you have to have the units designated. Whereas if the units cancel out, then it is unitless. There's no unit. It's just a number. Two ratios that have the same value are equivalent ratios. So let's consider the ratio of 12 to 9 as a fraction in simplest form. The ratio of 12 to 9 is equal to the fraction 12 over 9. Because if you're comparing 12 to 9, so how many 9s are in 12? Well, then we divide. That's what tells us how many of the second one fits in the first one. So this comes out to 4 over 3 in simplest form. We could also express this ratio as 12 to 9 is equal to 4 to 3. Okay, let's determine whether the ratios of 10 cups of flour in 4 batches of cookies and 15 cups of flour in 6 batches of cookies are equivalent ratios. Well, 10 to 4 is equal to 5 to 2. Now there are actually units here. You would end up with 5 over 2 cups per batch, because the units here are different. They don't cancel out. It's not unitless. Okay, 15 cups of flour in 6 batches. Well, 15 to 6 is equal to 5 to 2. So it's 5 over 2 cups per batch for both. Therefore, ratios are, well, okay, we should probably put the ratios are equivalent. Okay. Well, exercises. Write each ratio as a fraction in simplest form. 30 to 18. The ratio of 30 to 18 is equal to, well, 30 over 18. And in simplest form, both of these are multiples of 6. So it's 5 over 3. 5 to 25, well, that's 5 over 25, which is equal to 1 over 5. 49 to 35, well, they are both multiples of 7. Specifically, equals 7 to 5. That's one way we can communicate the ratio in lowest terms. But it says a fraction in simplest or lowest, depending on preferred terminology forms. So we should use the fraction. 7 over 5. 13 to 11, well, that's 13 over 11. And this is already in lowest form. as you can see from the ones I left as improper fractions before. However, if where you live lowest form does not include improper fractions, then this should be 1 2/3. So mixed fractions. And this would be 1 2/5. And this would be 1 2/11. Be aware of your regional conventions. 21 meters to 35 meters. Well, that's equal to 21/35, or they're both multiples of 7, so 3/5. Okay, 24 hours to 18 hours. Oh, the difference is 6 hours. They're both divisible by 6. Okay. That's going to be 4 to 3, or 4/3, which is equal to 1 1/3. Now 75 liters to 150 liters. 75 is half of 150. This is equal to 1/2. 12 boats to 48 boats. You can write 12/48 if you really want, but we can see that it's 12 and 4 times 12. So it's 1/4. Okay, determine whether these ratios are equivalent and explain. Well, 3/4 and 12/16. 12/16 is equal to 3 times 4/4 times 4. So we cancel those out, equals 3/4. Thus they are equivalent. Okay. 12 to 17 and 10 to 15. Well, 12/17 is equal to, 17 and 15 are co-prime, so we just multiply them to find the lowest common multiple. So 255. And then 12 times 15 is equal to 180. While 10/15 is equal to 170/255. So they are not equivalent. They're not equivalent fractions, therefore they are not equivalent ratios. Okay, 15/35 and 6/14. Well, 15/35 is equal to 3/7, because we divide both by 5. Okay, 6/14 is equal to, we divide both by 2, 3/7. Thus they are equivalent. So you show that they are equal to the same fraction. 2 pounds and 32 ounces versus 3 pounds to 45 ounces. Well, 2/32 is equal to 1/16, whereas 3/45 is equal to 1/15. So they are not equivalent. If you have two fractions with the same numerator and different denominators, they are not equivalent. If you have the same denominator and different numerators, they are also not equivalent. So yeah, you demonstrate ratios are equivalent by showing that they are equal to the same fraction or the same other ratio, whether simplified or, if you need to show that they're different, lowest common multiple or lowest common denominator. A ratio which compares two quantities that have different units is called a rate. For example, how many kilometers per hour is the car traveling at? Speed is a rate because it's a ratio of distance and time. Or say you have a muffin factory. How many muffins does it make per hour? One of the units is muffins, and the other one is time. When you have the rate simplified to have a denominator of 1 unit, such as however many kilometers per hour, i.e. per 1 hour, or however many muffins you make per hour, like per 1 hour, then it's called a unit rate. Suppose a vehicle drives 33 kilometers on 3 liters of fuel. What is the fuel mileage of this vehicle in kilometers per liter? Well, 33 kilometers per 3 liters of fuel is equal to 11 kilometers per liter. For a word problem, you put a statement like, this vehicle's fuel mileage is 11 kilometers per liter, but we'll skip that for time purposes. And because watching me write is perhaps not the most exciting thing you have in your day. And if it is, you probably need some hobbies. Or you need to do your homework, which is more exciting and more interactive than watching me write on the board. Example 2. Suppose there are 2 different sizes of chip bags available. The 120-gram bag costs $2.49, and the 180-gram bag costs $3.59. Which offers better value? Better value means more grams per dollar. So, 120 grams over $249 is equal to, we'll use an approximation. 120 divided by 2.49 is approximately 48.19 grams per dollar, and 180 grams per $3.59 is approximately 180 divided by 359 is approximately 50.14 grams per dollar. This is actually pretty typical. Generally, a larger package will offer better value for the most part. Sometimes you see a breakdown of this consistency that bulk sales or wholesale is better. If you're, say, buying computer storage, where it might be that the largest external hard drives are in fact not as good value as the second largest. But for the most part, the smallest ones are going to be significantly worse value. So it's something more like this curve in terms of how much value you get per dollar. Whereas the typical for wholesale goods is kind of like this, as you get bigger package size. Okay, so here, which offers better value? The 180 gram bag is better value. Now let's say we gotta find some unit rates and round to the nearest hundredth if necessary. 21 people in 3 vans. Well, 21 people over 3 vans equals 7 people per van. $165 for 3 books. Oh, that's $165 over 3 books. That is equal to $55 dollars per book. 115 kilometers in 2 hours. Well, that's 115 kilometers over 2 hours. So the units, you give them to the side, where the numerical part you just divide to find your unit rate. So this is going to be equal to 57.5 nearest hundredths, so 2 decimal places if necessary. This is just 1, no need to round. This is kilometers per hour. 8 strikes in 13 games. If this is for baseball, this person is probably pretty decent, or his team just loses a game so fast that he doesn't get any rotations on the field, really. Okay, so 8 strikes over 13 games is equal to 8 divided by 13, approximately 0.62 strikes per game. Now let's say we want to choose a best unit price, $12.99 for 3 pounds of nuts, or $21.49 for 5 pounds of nuts. Yeah, we could divide, or we could eyeball this. Like, this is a pretty easily estimable question. 3 pounds, $12.99. Oh, hey, $12.99 is divisible by 3. So it's 4.33, okay. 21.49, so $21.5 for 5 pounds. 21.5 divided by 5 is 4.3. Because the 20 divided by 5 is a 4, and then the 1.5 divided by 5 is a 0.3. So, yeah, this is less dollars per pound. Less dollars per pound is a better unit price. Less money per amount is a better unit price. More amount per dollar, or per whatever currency you use, is also a better price. But of course, if we want to math it out, it goes $12.99 divided by 3 is equal to 4.33 dollars per pound. LB is the short for pound, versus 21.49 over 5, which is equal to 4.298 dollars per pound. Each pound costs less for the 5 pounds, so 5 pounds has better unit price. 32-ounce bottle of apple juice for $2.50, or a 48-ounce bottle for $3.84. Well, 32 ounces for $2.50. 32 over 2.50 is equal to, not feeling in the mood to math this out manually, so 12.8 ounces per dollar, and 48 over 3.84 is equal to 48 divided by 3.84 is equal to 12.5 ounces per dollar. You want as much product per dollar as you can get. So the better unit price in this case is the smaller bottle, the 32-ounce one, which is really uncommon because a larger bottle has less material costs for the bottle itself. It also costs less to transport per unit of product. That's why wholesale is generally cheaper than retail, i.e. buying a lot at once is generally cheaper than buying small amounts. Wholesale is also sometimes known as buying bulk, depending on the product you're dealing with. Customary units. This is useful if you live in the United States or are simply interested in how some of the old imperial units converted to each other. The specific units may vary in amount, for example, US gallon versus imperial gallon, but they're both about 4 liters. Like the US gallon is like 3.8-ish liters. And thus the quart is very close to a liter. It's a little bit less than a liter. And the cup is usually taken, if you're baking and you only have measurements in metric for your baking equipment, a cup is basically taken as 250 milliliters because it's pretty close, reasonably so. So a cup is 8 fluid ounces. A pint is 2 cups. That's what it means if you get, say, a pint of beer. Like, it's actually still very common in the UK, I think, even though the British have converted to metric, to talk about going for a pint at the bar or at the pub. Pubs, also known as taverns, by the way, in case you don't recognize the word. It's like some place to get something to drink. Yeah, so a pint of beer would be almost 500 milliliters or around 500 milliliters, depending on which pint you're using, of beer. A quart would be 2 pints, it's about a liter, and a gallon is 4 quarts. Quart has, of course, the same etymology as quarters, which are 25 cents. A pound is 16 ounces, kind of like the old Chinese measurements where you had 16 of the smaller unit to one of the next larger unit. The smallest commonly used unit, that is. 1 ton is 2,000 pounds. The metric ton is a word that originated from the imperial ton, or the equivalents in French terms, because they had various different units of weights and measures depending on where you lived. So it's about 2,000 pounds or 2,200 pounds, depending on if you're talking about long ton or short ton. I should note that the metric ton has the abbreviation of lowercase t and is formally supposed to be spelled Tonne for metric ton. But of course, nobody really gives a wooden nickel about that. So, length, 1 foot is 12 inches, 1 yard is 3 feet, and 1 mile is 5,280 feet. Which makes it 1,760 yards. What an interesting choice of increment. Oh well. Sometimes old stuff doesn't have to make sense, guys. So let's do some of these conversions with this table as reference. Like just so that if you ever encounter a country that uses imperial, you have a vague clue of how many of each is supposed to correspond to one of the others. 5.5 pounds is how many ounces? Well, 1 pound is 16 ounces, so 5.5 times 16 gives us 88 ounces. 28 fluid ounce is how many cups? Well, 1 cup is 8 fluid ounces, so 28. We divide by 8, or rather multiply by 1 cup, like this. Fluid ounces times 1 cup per 8 fluid ounces. And of course the fluid ounces then cancel each other out. And 7 and 2. So you get 7/2 cups. That's how the conversion goes. That's how the units cancel out. Why am I showing you this? Because later on, checking if your units all cancel out correctly is very, very useful for error checking in, like, say, physics class or chemistry class. Okay, 5 pounds is how many ounces? 1 pound was 16 ounces, so 5 pounds must be 5 times 16, 80 ounces. 6 yards is how many feet? 1 yard is 3 feet, so 6 yards is 6 times 3 equals 18 feet. 8,000 pounds is how many tons? 2,000 pounds is 1 ton, so 8,000 pounds is 4 tons. 4 cups is how many fluid ounces? Well, 1 cup is 8 fluid ounces. So, 4 cups must be, 4 times 8 is 32 fluid ounces. Wait a second, guys. Do you notice something here? A pint is 2 cups. A pint also happens to be 16 fluid ounces. I just told you guys earlier that a gallon is roughly 4 liters. 4 liters. Depending on where you are, it can be a bit more or a bit less. What sort of gallon you're using. But a gallon is 4 quarts. And a quart is 2 pints. What does this mean? This means a pint is a bit less than, of course, depends on what pint you're using, half a liter. And what happens if you have half a liter of water? Oh, that's just a bit more than a pound of water. A pound is like 450 something grams. Okay, let's do some exercises. Convert 5 pounds to ounces. Well, a pound is 16 ounces, so 5 pounds is 80 ounces. 6 yards to how many feet? 1 yard is 3 feet, so 6 times 3 is 18 feet. 8,000 pounds to how many tons? Well, 2,000 pounds is a ton, so we're looking at 4 tons. 4 cups is how many fluid ounces? A cup is half a pint. A pint is half a quart, and a quart is a quarter of a gallon. Wait a second, guys. A gallon is around 4 liters. His US system, if I recall correctly, it's about 3.8 liters. Okay, then. That means a quart is a little bit under a liter. Well, then a pint would be a little bit under half a liter. Hey, what's a little bit under half a liter of water? What's a mass? 1 liter of water has a mass of approximately 1 kilogram. So actually, pound is a unit of force, by the way. It's not a unit of mass. Kilograms are for mass. Pound is weight. But on near Earth's surface, a little bit less than half a liter of water weighs approximately 1 pound. So 1 pint is about a pound of liquid if the liquid has about the density of water. The fluid ounce is a 16th of a pint. The fluid ounce is so named because it's an ounce of fluid. Whoa, it's actually pretty reasonable if you think about it like that. So, how many fluid ounces are in a cup? A cup is half a pint. A pint is basically a fluid pound, so 16 fluid ounces. Therefore, half of that is 8. So 8 fluid ounces per cup. 4 times 8 is 32 fluid ounces. Like that's, even if we didn't remember the conversion factor, we can reason it out using what we do remember. 1/2 of a gallon is how many quarts? Well, a quart is a quarter of a gallon. So 1/2 of a gallon is going to be 2 quarts. 6,864 feet is how many miles? Well, we know that 5280 feet is 1 mile, so 6864 divided by 5280 is equal to 1.3 miles. 9 pints is how many cups? We just said that 1 pint was 2 cups, so 18. 11 pints is how many quarts? Well, a pint is half a quart, so 11 of these is going to be 5.5 quarts. Now more unit conversions, this time in metric. This is the way they may present it to you in a North American math textbook. You can tell my opinion of this method because you want the TLDR, i.e. the summarized version of this? 10 millimeters equals 1 centimeter. 100 centimeters is equal to 1 meter. 1,000 meters is equal to 1 kilometer. And for units of mass, 1,000 milligrams is equal to 1 gram, and 1,000 grams is equal to 1 kilogram. So, kilo is the prefix used for 1,000. Milli is 1,000th, like 1 part in 1,000. And centi is the prefix used for 100th, as in 1 part in 100. You may also occasionally see units like megagram. A megagram is a million grams. It's also known as 1,000 kilograms or 1 metric ton. For liters, you will very, very, very rarely see kiloliters or even megaliters. For the most part, you're going to be dealing with milliliters, and 1,000 of those is equal to 1 liter. And these are basically it. As long as you have these down, you can do the conversions back and forth as needed. As long as you understand the math involved. So complete. 61 centimeters is equal to how many meters? Well, we know 100 centimeters is 1 meter, so we need to divide by 100 to get from centimeters to meters. 0.61. Complete. 2.7 kiloliters is how many liters? Well, a kiloliter is 1,000 liters, just like a kilogram is 1,000 grams. A kilosecond is 1,000 seconds. So, 2.7 kiloliters is 2,700 liters. Alright, let's do these exercises here. 52 kilograms is how many grams? Kilogram literally means 1,000 grams. So 52 kilograms is 52,000 grams. 52,000 grams. 7.2 liters is how many milliliters? Well, a liter is 1,000 milliliters, so converted, this is 7,200 milliliters. 927 millimeters is how many meters? 1,000 millimeters is 1 meter, so we divide by 1,000 to convert. 0.927. 0.22 centimeters is how many millimeters? Well, 1 centimeter is 10 millimeters, so we multiply by 10 to go from centimeters to millimeters. It's 2.2 millimeters. 5.4 grams is how many milligrams? Well, 1 gram is 1,000 milligrams, so we multiply by 1,000 to get 5,400. 2,700 milligrams is equal to how many grams? Be warned that in some places, the comma is used as the separator for decimals, not the period. So it's not the dot, it's the comma in some places. This is not one of those places. So this is 2,700, not 2.700, okay? So, this many milligrams, 1,000 milligrams is a gram, so we have to divide by 1,000 to convert, so it's 2.7 grams. 2.66 meters is how many centimeters? Well, a meter is 100 centimeters, so we have to multiply by 100 to convert from meters to centimeters. It's 266. Now, algebra, solving proportions. A proportion is an equation that says two ratios are equivalent. Rates are types of ratios, so they can also form proportions. For example, if I'm saying that two cars are going at the same speed, well, that's a proportion, because speeds are ratios. They're ratios of distance and time. In a proportion, a cross product is the product of the numerator of one ratio and denominator of the other ratio. This is because multiplying by both denominators results in what we call cross multiplication. So, if we cross multiply, we get for 30 and 30. We see that the numbers match up, which means that this is a proportion. A proportion. Or these are proportionate. Like these two fractions. They're the same ratio. They're equivalent ratios. So example 2. Solve 8 over a is equal to 10 over 15. Well, we cross multiply and we get 10a is equal to 8 times 15, which leaves us at 120. So a is equal to 12. Okay. Exercises. Determine if the quantities in each pair of ratios below are proportional. So if the equations are true. And explain. Alright then. 8 over 10 equals 4 over 5. You start by assuming that the equation is true, and then you cross multiply and you get 40 equals 40. Equation true. True. Therefore, it's proportionate. Or proportional as used here. 6 over 14 and 9 over 21. Well, let's try it out. Yes, we can also see that if we simplify each of them, we end up with the same thing, but here we're doing cross multiplication. So 6 times 21 is going to be 126, is equal to 14 times 9. Well, we have a 90 and then a 36, so 126. True. And therefore, these two ratios are proportional. Now, 2.48 for 4 ounces versus $3.72 for 6 ounces. Well, 6 times 2.48 gives us, well, there's no units, so we're not going to use units yet. There's no units that are relevant to us here because we see that the units are clearly going to match up. It's going to be dollars times ounces for our unit, which is usually something that for our grade level, it seems a little sketchy to a lot of students, so we don't really bother with it. Just make sure that the units are the same, and that's good enough. You don't have to conceptually understand the units. 15.88. Therefore, this is true. Thus, the ratios are proportional. 125 miles for 5.7 gallons versus 120 miles for 5.6 gallons. We cross multiply 125 times 5.6, 700. And 120 times 5.7 is 684. No, they're not equal. Not proportional. Yeah, we should note down that these are actually unequal. So solve each of these proportions below. Y over 7 is equal to 16 over 28. Well, you could just multiply over by 7, but we're supposed to use cross multiplication. So for this one, yeah, okay, cross multiply. 28y is equal to 7 times 16. Okay, fine. Let's do this. 112. Y is equal to 4. We could just have canceled things out and it would have been fine. Like you could have just gone, okay, this is 4 now. Oh, this now cancels here. Therefore, this is now 4 and this is 1. Done. Here, though, you kind of have to multiply over. But you can still do some canceling beforehand. So W is equal to 3 times 15, which is equal to 45. Now for 20 over B is equal to 70 over 28, you can cancel out a 10 right away. You can cancel the 7 and turn this into a 1 up here and a 4 down here. So B is equal to 2 times 4 once we cross multiply. B is therefore equal to 8. Alright. This next one, 52 over 8 is equal to m over 9. What can we cancel out right off the bat? Oh, we can get rid of a 4. Well, divide by 4. 13 over 2 is equal to m over 9. 2m is equal to 13 times 9. So 117. M is equal to 117 over 2. As you can see, we might as well not have bothered with the cross multiplying bit if your variable is only in the numerator. Yeah. But hey, it's cross multiplication practice, right? Okay, obligatory problem solving section for every chapter of a North American textbook. Problem solving, draw a diagram. When you are solving problems, a diagram of some sort will often be useful for showing what you have and what you need to find. Suppose you need to jump into a circle from the starting line in as few jumps as possible. And after 3 jumps, you have gone 9 meters. Three jumps, 9 meters. And this is 3/4 of the way. So you list out what you know. And how far is the target from you? So you want to know this distance. This is the question mark. You want to know the remaining quarter. 9 meters is 3/4. So remaining quarter, remaining 1/4 is, by this proportion, 9 meters to 3/4 is equal to, remaining 1/4 is, say it's x meters, okay? X meters to 1/4. Now, what does this actually do? This is 9 over, actually this should be a long dash. It's over a fraction. Equals x over 1/4. Now you can actually cancel the quarter part right out. Like this ratio here is going to be 3 to 1. So, what next? Well, 9 over 3 is equal to x over 1. X is equal to 3 meters. You are 3 meters from the target, or 1 jump, depending on what unit you prefer. Of course, that I might have shown a few more steps than strictly necessary there, but the point remains that drawing a diagram is occasionally, actually useful. Suppose $1,800 is about 1/7 of the price of the new car you want to buy. How much more do you need to save in order to buy the new car? Well, in this case, this is an 1,800 over 1/7 is equal to rest of savings needed over 6 over 7. Because dividing by a fraction just means multiplying by the reciprocal, that would be times 7 and then times 7 over 6. These two places, these two 7s, they correspond in position and can be just canceled out right away. So by cross multiplying, savings needed is equal to 1,800 times 6. So 10800. And this is, of course, in dollars. Okay, suppose you're going traveling. You're traveling 200 kilometers, and that puts you 4/5 of the way to your destination. How far is your destination? Well, 200 to 4/5 is equal to 50 to 1/5. So you have 50 kilometers left to go. Or, depending on what the question actually means, how far away is your destination? Could be how far is your distance traveled. So 250 kilometers total distance. A scale drawing is something that's too large or too small to actually show at actual size or build, as the case may be for a scale model. So the scale gives you the relationship, so the proportions, the ratio between the drawing or model measure and the actual measure. Often in everyday life we use proportions and ratios interchangeably, but this should really not be the case. So on this map, each grid unit represents 50 meters. Find the distance from Patrick's Point to Agate Beach. Well, it's 1, 2, 3, 4, 5, 6, 7, 8 grids. 8 grids. And then you multiply by the scale, which is 50 meters per one grid. You multiply by the scale with the units in the appropriate places. By the way, if it was asking you how many grids would 500 meters be, you would be going 500 meters times one grid per 50 meters. So you cancel out the grids, and then you end up with 400 meters for the distance from Patrick's Point to Agate Beach here. Let's find the actual distance between each pair of cities. Round to the nearest tenth if necessary. Los Angeles to San Diego in California. That's a map distance of 6.35 centimeters on a scale of 1 centimeter equals 20 miles. Well then, 6.35 centimeters times 20 miles over 1 centimeter. The centimeters cancel out. In other words, times 20 is 127 miles. Lexington and Louisville, Kentucky. Well, that's 1 centimeter for 5 miles. And you have 15.6 centimeters. So 15.6 times 5, which is 78 miles. Des Moines and Cedar Rapids, Iowa, 2 centimeters is 15 miles. And you have 16.27 centimeters. Well, how many 2 centimeter sections do you have? 16.27 divided by 2 times 15. Or you could just multiply by 15 over 2, which is 7.5. So this is 122.025 miles. Miami and Jacksonville, Florida. Half a centimeter is 20 miles. So 1 centimeter is 40 miles. And it's 11.73 centimeters. 11.73 times 40 is 469.2 miles. This seems a little bit off here. I do believe there was an error made on this map somewhere. Because almost 500 miles is a long, long way. And I don't remember Jacksonville being that far from Miami. Oh well. Now suppose you're making a scale drawing and you find the length of each object on the scale drawing with the given scale. Then find the scale factor. So you have an automobile that's 5 meters long at a scale of 1 centimeter to 5 centimeters. actually, you should find the scale factor first. Scale factor is 1 to 5, 1/5. So, the length of the object, 5 meters, times the scale factor, which is this. Cancel out the centimeters, and you end up with 1 meter. I gotta say, this is actually a reasonably large scale model, or drawing. If it's just a 1/5 scale, huh. Oh well. A river 120 meters across, 1 centimeter is 40 meters. So 120 meters times 1 centimeter per 40 meters will put us down to equals 3 centimeters. And the scale factor is 1 centimeters over 40 meters is 40 times 100, 4,000 centimeters, which is equal to 1 over 4,000. Let's say we have a parking lot. It's 200 meters wide, and we're representing it at a scale of 1 centimeter to 25 meters. This is 1 centimeter per 2,500 centimeters, which is equal to 1 over 2,500. 200 meters times 1 centimeter over 25 meters. So this is going to be 8. So 8 times 1 centimeter, that's 8 centimeters. That is the width of the parking lot on your diagram. Fractions, decimals, and percents. Well, let's write some of these percents as fractions. 5 and 5/8% as a fraction in simplest form. Okay, 5 times 8 is 40, plus 5 is 45 over 8 over 100. Percent means per 100. So, that's equal to 45 over 800. What can we cancel out here? Oh, we can cancel out, clearly, a 5. So 9 over 160. So 9 over 160 is what we're looking for simplest form. Now write 7 over 16 as a percent. Well, we use a calculator. 7 divided by 16 is equal to 0.4375, which is equal to 43.75%. Okay, exercises. Write each percent as a fraction in simplest form. 40% as a fraction in simplest form is equal to 40 over 100, which is, as it cancels to make 2 and 5, so divide by 20 for both top and bottom, so 2/5. 77 and 3 over 4%, that's 77 times 4, 308 plus 3, 311 over 4 over 100. So it's 311 over 400. 400 only has 2 prime factors. 2 and 5. Okay, is 311 divisible by either? No. Therefore, as a fraction in simplest form, it's just this. 27.5%. Well, 27 times 2 is 54 plus 1, 55 over 2 over 100 would leave us at 55 divided by 5 is 11. 100 divided by 5 is 20. So 11 divided by 2 divided by 20. 11 over 40. That's a fraction in simplest form. Because there are no common factors between numerator and denominator. 37.5%. Well, that's 37.5 over 100. Which, by the way, cancels out to be 3 over 8. Because we can divide both top and bottom by 12.5. So this is equal to 3/8. Well, let's write each of these fractions as a percent and round to the nearest hundredth if necessary. 2 over 5. You don't need a calculator for this one because 2/5 is just 40%. Or 0.4, 40%. 5 over 8. Well, 1/8 is 12.5%. So if you didn't remember that, you might use a calculator here. You get 0.625, which is 62.5%. 11 over 16. Yeah, remembering what 1/16 is not that much worth bothering with. So if you use a calculator, you find equals 0.6875, which is equal to 68.75%. Now 2/3. 2/3 is 0.6 repeating, which is approximately, it said round to the nearest hundredths if necessary, that means hundredths of a percent, 66.67% approximately. Okay, what happens if you have a percent greater than 100% or percent less than 1%? Well, if it's a percent less than 1%, it's a number that's less than 1 in 100 or 0.01. If it's a percentage greater than 100%, it's a number greater than 1 because 100% is equal to 1. Write each percent as a decimal and as a mixed number or fraction in simplest form. 330%, that's equal to 3.30, or 3 and 3/10. 9,012% is equal to 90.12. What else could it be? Oh, fraction in simplest form. 90.12 is also equal to 90 and 12 over 100, which is equal to 90 and 3 over 25. Yeah, that's a mixed number. That's a decimal. So, let's write these decimals as percents. 1.35. Well, there's a reason sometimes the conversion to percent is written out as times 100%. So this is 135%. And here, 622.5713, we just need to move the decimal place 2 places and then add a percent symbol at the end. 0.13%. Okay, exercises. Write each of these percents as a decimal and as a mixed number or fraction in simplest form. 200% is equal to 2. I mean, technically it's 2.00 because here all 3 digits are specified. Mixed number or fraction in simplest form, well, equals 2 for the mixed number. Yeah. Okay, 324%, that's 3.24, which is equal to 3 and 24 over 100, which is 3 and 6 over 25. 0.456% is equal to 0.00456, which is equal to 456 over 100,000. And what can we cancel there? Oh, 456 divided by 4. We can see that. Actually, we can divide by 8. Oh, we get down to 57. 57 and 2500. Okay. So let's say we want to write each of these decimals as a percent. But the first number has no decimal. Well, that's because 17 is a whole number. As a percent, it's equal to 1700%. 3.14? Oh, there's a reason people can write it as times 100%. It's 314%. 0.001? Well, that's equal to 0.1%. You move the decimal 2 places and add a percent symbol. Same thing here. 0.0019? Well, that's 0.19%. And this last one, 0.006786112. Move the decimal place 2 places. 8612, and then add a percent symbol. Yeah. Okay, so as we can see, ratios can be compared to each other. And when we compare them, we can use cross multiplication to show that they are equal. Or actually just multiplying one denominator sometimes, depending on what sort of question you're doing. It can be enough to get the job done. And we can see that percents are just another type of ratio, just as we showed before that they're just another type of fraction. And as with fractions, decimals in general, and ratios in general, they are easily interconverted. So that's it for this chapter. See you next chapter.